Okay, so this problem says the partial pressure of carbon dioxide in the lungs is 470 pascals when the total pressure in the lung is 1 atmosphere. So the pressure of air in your lungs is always 1 atmosphere. What percentage of air molecules in the lungs is carbon dioxide? Okay, compare the result to the percentage of carbon dioxide in the atmosphere, which is about 0.033%. Okay. Now, if you check your notes, when you have a mixture of gas exerting a pressure, the partial pressure is the pressure due to individual components. Okay. And so the partial pressure is given by this ratio. Okay. What this says is the pressure exerted by this component is equal to the fraction of that component. If there's 10% of those molecules, the partial pressure is 10% of the total pressure. That's what this equation is saying here. Okay. All right. So what percentage of this is? So N I by N is PI by P. Okay. So the pressure is 470 pascals. That's the pressure due to the carbon dioxide molecules. And the total pressure is 1 atmosphere, which is that. So the fraction of carbon dioxide molecules, okay, so we'll explicitly write it. Fraction of CO2 molecules is equal to okay, again, this is just a number, the units cancel, this is just a number, and so the percentage is 470 into 10 minus 5 into 100%, okay, so 10 minus 3.47%. Okay, so what we are saying is when you breathe out, 0.5% of the molecules are carbon dioxide molecules. That's what we are saying. Compare this result to the carbon dioxide in the atmosphere, which is 0.03%. Okay, so we'll just take the ratio, but let me add a page below. Oops. Okay, so what do we do? Ni by N when you're breathing out, and Ni by N when you're breathing in. This ratio is what you're calculating. And Ni is the carbon dioxide molecules to air molecules when you're breathing out, and okay. So that's what you're calculating, and that's 0.47% divided by 0.033%. All right, so what you did was when you breathed in and when you're breathing out, the concentration, CO2 concentration level is 14 times greater. That's what we've said, we are saying. Okay? And so how did we make that possible? And you have very little time to do it. So here's blood, and there's CO2 in the blood. So the concentration of CO2, okay, so here is the concentration of CO2 in the lungs and the air. Okay, when this concentration is much higher than that, this CO2 leaks out. So the concentration of CO2 in your blood is quite high, and that's why this, as the blood is passing through, you have half a second for the lung to pass through. This carbon dioxide goes in there. That's how you get rid of carbon dioxide. Okay. All right. That process is called osmosis.